Here is the solution to question 3 of your test on rational functions, equations and inequalities. While these are very good questions, they are communication and thinking questions, so you need to explain all what you do. So I'll give you a kind of explanation here, listen to it very carefully and see how we derive at the results. Question 3. Determine a possible equation for a rational function with following set of properties. 0 at -1, vertical asymptotes along the line x equals to -1.5 and x equals to 4, a removable discontinuity at x equals to 2, and a horizontal asymptote along the line y equals to 1. One of my recommendation here is that you should go through set of videos where I have actually 5 videos which explain you how to write equation of a rational function with given conditions like the one before you, right? So if you have not got it yet, then go through those videos and try to get it on your own. That will give you more confidence. So those are the application questions, and this is an extension to the same. There is more thinking involved here. So let's try to develop the equation now, okay? So let's say the rational function is f of x for us, and now we'll just fill in and see how we can develop this equation. Good point to start is always, I should say, vertical asymptote, right? Because vertical asymptote gives us the denominator, right? Something, a base to work with. That is kind of important, right? So it says vertical asymptotes along the lines of x equals to -1.5. So 1.5 is like 3/2, right? So what we can write here, and that to -1.5. So we can write this base denominator factor as 2x plus 3, right? How do I get this? So basically, let me show you some rough work here. How do I get this? So vertical asymptote at x minuses, that means my factor is x plus 1/5. It's good to write in fractions, x plus 3/2, right? So x plus 3/2 is our factor, so I can write 2x plus 3. Is that okay? So that is how I get my 2x plus 3 factor. This is for this decimal thing. So I've purposely taken this vertical asymptote, the only one in this set with a fraction, now written in decimal form. So right, in this case you prefer a fraction, not decimal. And at x equals to 4, that means the other factor should be x minus 4. So if I put 4 here, that becomes 0. If I put 1.5 minus here, 2 times 1.5 is -3, and -3 plus 3 is 0. So these two ensure vertical asymptote at these points. Now the next condition which we are going to look into, so I'll write this as step number 2, and that should be my step number 2. So yeah, the first one is vertical asymptote, second removable discontinuity at the point given to us is x equals to 2. That means we have a factor in numerator and in denominator, right? And that is the factor x minus 2, correct? So this factor x minus 2, both in numerator and denominator, will actually cancel out and lead to a whole. That gives us a whole, you know. And then we can do any of these. So one is, let's go for zeros, or doesn't matter. Horizontal asymptote along the line y equals to 1. Now if there is a horizontal asymptote along a line y equals to 1, that means what? It basically means that degree should be same of both numerator and denominator, right? So that is the meaning of this equation. Now how do you get the same degree? Here the degree is how much? 1, 2, 3, and here it is only 1. So we need to make degree same, right? So that means the degree of numerator should be 3, right? So that gives us degree of numerator should be 3, right? Now let's look into zeros at x equals to -1. So when we say zeros at -1, it means our point is actually -1 and y value is 0, correct? That is what we mean by zeros at -1. And it also means that if I write -1 in x, then I should actually get 0 in the numerator. Now with this x minus 2, I'm not going to get 0 in the numerator for x equals to -1. So that means there is a factor in the numerator which will make it 0, and that factor happens to be x plus 1. This is the factor which is going to give us 0 in the numerator. So we'll go to this step, and that becomes our step number 3. So step number 3 gives you a factor in the numerator where if I put in x as minus 1, so if I put x as minus 1, this becomes 0 and everything thereafter becomes 0. See, nothing else becomes 0. Important to see. Okay. So we have got this. Now let's get back to the fourth, the last part, which says horizontal asymptote along the line y equals to 1. Now, horizontal asymptote can be 1 if that means the leading coefficient should be same and degree should be same of both numerator and denominator. But you know what? We have a different degree here. We have degree of 2 and 3. So let's make it square it. If I square it, now the degree is same for us, correct? Now it's perfectly fine. These two cancel out, giving us a whole, and that gives us a 0 at minus 1 and degrees are same. But if I see coefficients, I have a coefficient of x cube with 2. Here x cube coefficient is just 1. To make it same, I need to multiply this by 2. Correct? So if I multiply this by 2, now horizontal asymptote will be along the line y equals to 1. Do you see? So that is the process by which we can develop an equation for a given condition. So that is my final answer, and I hope you understand the way we derived at it, right? So most of the time when you have to write an equation for a rational function, then the sequence to be followed is look for the vertical asymptotes, look for removable discontinuities, zeros, and then horizontal asymptotes. In this sequence, if you do your things, then you'll get the correct equation in minimal time. That is kind of very critical. I hope you appreciate it. Share your comments and share the video with your friends. Thank you.